Assalamu alaikum students. This is a small video. I'm Dr. Naveed. I wanted to explain that how to do dry runs in the algorithms where we have conditions or decision structures and also repetition structures. So I've got two problems here. One which has decision structures in the form of if-else condition, and the other problem where I will use a loop, a condition control loop, a while loop, and I'm going to explain that how to do dry runs and what are the things that you should consider when you are doing a dry run. Okay, so the first problem is that you need to write the algorithm of a program that reads three numbers and outputs them in increasing order. So essentially what you're supposed to do is that, for example, let's say the user enters numbers like 3, 1, and 2. So these are the three numbers that user has entered. The output should be 1, 2, and 3. Or you can imagine that the input can be, for example, 5, 3, and 2. Then essentially you don't need to change anything, because so you actually have to reverse the output. So the output would be 2, 3, and 5. And you can imagine that there can be as many inputs, or there can be a whole variety of inputs that a user can enter. So what is the purpose of doing a dry run? First of all, we need to understand that whenever we are trying to dry run an algorithm, the objective is to identify any logical mistakes that you might have made in designing the solution to a problem. Okay, and the key thing to remember that whenever we are doing dry run, the algorithm that we have written, it is important that all the statements in the pseudocode, they are numbered. Because then we can easily identify that which statement is causing the problem. And another important thing to remember that logical mistakes can occur in the form of wrong values being stored in the variables. Okay, so essentially what we want to track during the dry run is the values of all the variables. The variables can be, for example, in this particular algorithm, as I have declared 4 integer variables. Here you can see that these are the 4 integer variables that I have declared. For example, num1, num2, num3, and I have also a fourth variable with the name temp_var. So these are the 4 variables which are, so 3 variables are where I'm going to get the input from the user, and then I have declared a fourth variable, which I'm going to briefly explain that where to use. So first thing, as I was saying, it is important for us to number every statement, as we have seen in the past as well, that with the pseudocode we number each statement. And second thing to remember is that we want to track the values of all the variables throughout the execution. So for example, in our particular scenario, we have these 4 variables, num1, num2, num3, and temp_var. So we want to track the values of these variables. Another thing that can vary during the dry run or during the execution of a program is the values of these relational expressions. So for example, in this code, you guys can see that I have this if statement. So it is starting here and it is ending here. Then I have another if statement which is starting on line 10 and ending on line 18. And if you look at these two statements closely, then we have this condition where I am checking if number 1 is greater than number 2. And on line 10, I have another condition where I'm checking number 3 is less than number 1. And within this if else, I have another nested if else. So here I'm checking if num3 is less than num2. So apart from the values of the variables, we also want to track that what will be the values of these Boolean expressions. So whenever we are doing dry run, so it is important not only to track the values of variables, but also we want to track the values of these Boolean expressions, because remember, depending on the input values, the values of these expression or the value to which these expression is going to evaluate, this is also going to change. So let's see. So what do we need to do when we are doing a dry run? So it's always a good idea to think of that, you have a big table where, you can, so essentially what we need to figure out that which columns do we need to add in this table. So first of all, the first column should be for the instruction number. So, so this column is where I will go through my code one by one, instruction by instruction. And then the rest of the column should be, there should be one column for each variable that we have in our code. So for example, For num1, we will have one column. We will have another column for num2. We will have a column for num3. We will have a column for this variable temp underscore var. And we also need columns for these Boolean expressions. So we will have one column for this expression num1 is greater than num2. We will have a column for the other expression num3 is less than num1, and another column for the third expression where we have num3 is less than num2. So please bear with me because because due to lack of space, I want you guys to see the dry run along with the code. So that's why it has got slightly messy. So we can just draw the lines so that we can easily see that what could happen to the values of each variables as we sort of do the dry run. So this was for num3, and this column is for temp underscore var. Then we have essentially three columns for these Boolean expressions. So remember, we have three Boolean expressions. This is the first Boolean expression, and this is the second Boolean expression, and this is the third Boolean expression. So essentially, we have 1, 2, 3, 4, 5, 6, 7 columns, 4 for these variables. So we have 1, 2, 3, 4 variables, and we have 3 expressions. So we have 7 columns in all. So let's try to do one dry run of this algorithm. So let's say we start with instruction number 1, and we need to go and see what's happening. So when the instruction number 1 is executed, we have declared our integer variables. So we have declared num1, but we have not initialized them. So we essentially do not know what is actually present in these particular variables, what value these variables actually hold. Similarly, because these expressions, they are not evaluated, so we yet do not know what is the values of these expressions. So this is line number 1. Similarly, we can go to line number 2, and since line number 2 is just displaying something to the user, so essentially there is no change in the values of these variables, so they are going to stay exactly the same. So now we come to line number 3, and this is where you see that something is going to change. So line number 3 is where we are asking the user to enter the values for these 3 numbers. So let's say that the user enters values in the form of, let's say user enters num1 as 3 and num2 as 1 and num3 as 2. So these are so remember that the dry runs, they are dictated by the values which are being sent as an input to the program. So in this particular scenario, the dry run is going to depend on these 3 numbers which are being entered. So now we know the values of num1, num2, num3. So we can see that their values are changed, but still temp var is not been assigned any value. So we still don't know about what is being stored in temp var, and same is the case with the other expressions. And as you can see, line number 4 is just, I've just written a comment here for you guys to know that within the pseudocode, or when you're doing the dry run, there can be empty spaces or white spaces in the pseudocode. So you don't need to include them in the dry run. So you can just skip line number 4 and move to line number 5. So line number 5 is also very important here. Why? Because here we have a Boolean expression, or the first expression here, num1 is greater than. So we are actually going to see if number 1 is greater than number 2. So remember, in our dry run, number 1's value is 3 and num2 values is 1. So let's, there is no change in the values of these variables, so they are going to stay exactly the same. And temp underscore var, we still did not initialize it, but here now we are going to evaluate this expression. So either you can write true or false, which will tell us that what is going to happen if this condition is obviously true, then we are going to come inside this f. But if this condition is false, then we are not going to come within this if statement. So, but in our scenario, number 1 is 3 and number 2 is 1. So 3 is greater than 1. So this condition is true. So because this condition is true, so what is going to happen? Line number 6 will be executed. So you can imagine another set of inputs where number 1 was, for example, number 1 was 1 and number 2 was 3. Then this expression would have been wrong. So the next statement would have been line number 10. But in our dry run, and with the set of inputs 3, 1, and 2, we are going to go to line number 6. And in line number 6, we have a assignment statement where we are setting the value of temp underscore var to num1. So remember, num1 was 3. So now temp underscore var would also become 3. And you can say that this expression, so here this expression was important because our decision dependent on it. So you can say that this was essentially true, and we still don't know about the rest of the expressions. So, and then we are going to go to line number 7. So in line number 7 we will have 3, and so we are setting num1 equal to num2. So it won't be 3, it will become 1, and there is no change in the value of num2, so it will also be 1. Num3 will be 2, and our temp underscore var is 3. And so our this boolean expression was true, so we just leave it like that. And so when we go to line number 8, so this is okay. So one thing that you need to remember about these Boolean expressions, that it is not important, what you write here, because, here it was important. Why? Because here the value of this expression, was controlling that the behavior of our code. So if it was false, we would have moved to line number 10, but here, because it was true, so we moved to line number 6. Okay. So here you can even, leave them as, hyphens or dashes. So it doesn't really matter here. So if we go to now line number 8, so you can see that in line number 8, now we are setting num2 to be equal to temp underscore var. So our num2 would become now 3, and our num3 is 2, and temp value is 3. So we can just, leave them as facts. So, and again, line number 9 is, nothing is going to happen, because this is just a statement which is telling that, the if block is going to end. So everything would stay the same, and, nothing is going to change. So now we move to line number 10. Line number 10 is also important because remember, here we have our second Boolean expression, and its value is going to change, and we want to track the change in its value because it controls the logic, or it controls the functioning of our solution. So here we are saying that where we are trying to check. So remember, the value of these 3 variables is important. So here we are checking if number 3 is less than number 1. So now remember, our number 1 has become 1, and number 3 is 2. So so this condition is essentially, so num3 is less than num1. So this condition is false. So because this condition is false, so what is going to happen? This statement, or statement number 11, will not be executed. So we won't execute this statement, and we will come to this else part. So we'll come to line number 12, or statement number 12, skipping statement number 11. So again, there will be no change here because this is just the else block starting. So we're going to just leave it like that. And now we'll move to line number 13. And in line number 13, or statement number 13, we have another condition where we are trying to evaluate that if number 3 is less than number 2. So it is exactly the case. Number 3 is 2 and num2 is 3. So 2 is less than 3. So what we would do is we will say that our third condition is true here. So because the third condition is true, so what we are going to do is we are going to be coming here in this if block. Okay, I made a small mistake here, because when we are writing pseudocode, so after if we need to write then here as well. So we would come on and execute line number 14. So line number 14 is not going to change anything. It is just because remember our program, or the problem was that we wanted to output the numbers in increasing order. So now we know that our order is incorrect. So what we are displaying to the user is we are going to display to the user. So, these values are going to stay exactly the same. Nothing is going to change here, but our display statement is going to display the numbers in the order number 1, which is 1, and number 3, because remember number 3 is less than number 2. So it is going to print number 3 first, and then it is going to print number 2, which was 3. So our output is absolutely correct, which we wanted, that we wanted to print the numbers in increasing order. So just to quickly wrap it up, that this was, and obviously once we execute this statement number 14, then the next statement that will be executed is statement number 18, which is the end if statement, and nothing is going to change. So it is going to say exactly the same, and this will be the end of the dry run. So remember, the dry run is dictated by the values which are being sent as input to the program. So for a different set of values, our dry run, or the table where we do the dry run, it might look completely different, because remember the conditions are essentially branches in our code. So they dictate, so the values of the variables dictate that which branch we choose. So this was the first example that I wanted to discuss with you. And remember that the columns that we added when we are doing the dry run, so we had one column which was showing us the instruction number or the statement number, and so we need the code, or we need the pseudocode in the form where each instruction is numbered. And then we had one column each for a variable. So we had 4 variables, so 4 columns for num1, num2, num3, and temp respectively. Then we added 3 columns because we had 3 Boolean expressions here, okay, or 3 conditions. And why that is important, because depending on the decision, or depending how these Boolean expressions evaluate, our code or different statements would be executed. And that is what we want to track in the dry run. So apparently, just by doing one dry run, we can say that our code is working fine. But remember, doing one dry run may not be sufficient, okay? Because currently we only tested our program for the input 3, 1, and 2. So remember, you can give a different input, and then the dry run would be completely different. So one of the questions which students commonly ask, that why do we need to do multiple dry runs? Because your logic can work with one set of input variables, but it may not work if you change the order of these numbers. For example, let's say we entered number in the form 1, 2, and 3. So number 1 is 1, number 2 is 2, and number 3 is 3. Then the dry run might be completely different. Okay, so that was the first example. I hope this was helpful. The second example is where we need to have a repetition structure. So the statement says that a large company pays its salesperson on a commission basis. Each salesperson receives rupees 2,000 per week plus 9% of their gross sales for that week. So for example, a salesperson who sells rupees 50,000 worth of chemicals in a week. So a salesperson, this is the sales amount of a salesperson. This is just an example. Say that he is selling 50,000 worth, rupees 50,000 worth of chemicals he has sold in a week. And so how we are going to calculate the salary is that 2,000 is the base salary, plus we are going to give him some commission. So commission would be of the amount of the sales. So commission would be 9% of the sales that he has made. So 9% of 50,000 becomes 4,500. So the total salary for that salesperson then becomes 6,500. So we need to write an algorithm which actually does that. Obviously, just writing this algorithm for one salesperson, we don't need a loop, right? So in order to sort of modify this problem so that it includes a repetition structure, this line is important. So we've added this statement that develop the algorithm of the program that accepts each salesperson's gross sales for last week. So imagine that we have multiple salesperson and we do not know how many salesperson. So we don't really care because we are just trying to demonstrate something. So we don't know how many salesperson there are, but what we are trying to do that for each salesperson, we are trying to calculate his or her salary. So what the user is going to do, user is going to input the gross salary of a or the sales of one salesperson, and on the basis of that, our program is supposed to calculate and then display the salary of the salesperson. But remember, we are saying that we don't know how many salesperson there are. So essentially, we cannot use a repetition control repetition structure. So we need a condition control repetition structure. So what is the condition for termination? So the program should terminate if the user enters a negative value. Okay. So our condition for exiting the loop or coming out of the repetition structure is that as soon as the salary of the any salesperson is entered as a negative value, we are going to come out of it. So this is the algorithm that I have written for it. So again, remember, we need just one variable here. So again, it could have been easily I could have declared it as a real number, but I have chosen an integer. So I think real would be better, but just for demonstration, I just said that this is an integer, and I've written gross underscore scales as the name of the variables. Okay, remember the rules that we set for ourselves for naming variables. And as I said, and I've mentioned repeatedly in the lectures, that your names of the variables should be meaningful. Okay, so that by looking at the name of the variable, we can exactly know which kind of data this variable is going to hold, or what is stored in that particular variable. So and then we're going to display a message to the user that enter the gross sales for the last week, and then we are going to accept this input and store this in our variable that we declared here in statement number 1. And again, this is just white spaces or an empty line. I've just put a comment here. And then here is where we are, sort of using a repetition structure, okay? Because remember, we want to calculate the salaries of salesperson as many, as there are, okay? So a condition is that the program should terminate if user enters a negative value. So we are saying that we want to stay in this while loop as long as the sales amount which is being entered here is greater than 0. Okay, so imagine that the first input that the user enters is a negative number. So what is going to happen? What do you think is going to happen? If the first number that the user enters is a negative number, then we will not be coming in the while loop, and we'll straight away jump to statement number 9, and that will be the end. But if the user enters a positive integer, then we will come in this while loop. We are going to execute this statement. So this statement is sort of, we are evaluating a big expression here. So there are no variables whose values are essentially changed here, but we will be evaluating this expression, and we're going to just display a message to the user. And then we'll execute statement number 7. And in statement number 8, we are again taking the input. So remember, because this is a condition controlled repetition structure, and our decision whether to stay in the loop or go out of the loop depend on the value of the gross sales. So we need to update it. So we need to again ask the user to enter the gross sales for the next user. So that's why we have this display statement here, and we are again taking the input. So this is the solution. So let's look at the dry run of this particular code and see what it looks like. So remember that we said that we need a column where we can write the instruction numbers, because each of these statements in our pseudocode, they are labeled and or numbered. And then we need a column, we need one column for every variable that we have in our algorithm. So in this particular example, we only have one variable with the name is gross sales. And then we have we need, if you remember from the previous example, I mentioned that we also need a column, or we want to track any Boolean expressions that we might have in our algorithm. So in this particular example, we have a Boolean expression, which is this expression, where we are trying to evaluate if the gross sales are greater than 0 or not. So we will have two columns essentially here. So this is a relatively, sort of simpler, or it should be relatively simpler dry run. But we would see depending on the values that the user is going to input. So let's start the dry run. So let's say, so the first statement says that we are declaring this variable gross sales. So this variable is declared, but we do not know what's in this variable. So we're just put a question mark here, and we don't know how this expression is going to evaluate yet. So we just put a hyphen here. So then we go and execute statement number 2. So essentially it's just a display statement. So nothing is going to change. This is going to stay exactly the same. And then we go and input or go to statement number 3. So what do you think is going to happen? So the user is going to enter a value for gross sales. So let's say user enters a negative number. So let's say user enters minus 10,000. Okay. So remember that, so user enters a negative number. And again, we don't know, what is going to happen with this Boolean expression. And remember, as I said earlier, that line number 4 is just an empty line or a white spaces. So we don't really want to, even consider that when we are doing the dry run. So just leave it as that and move to statement number 5. So in statement number 5, this Boolean expression is going to be evaluated. So remember, the value of this variable is negative 10,000 or minus 10,000. So the expression says if gross sales is greater than 0. So this expression is wrong, because the value of gross sales is less than 0. So this becomes false. Now, because this is false, the statements 6 to 8, they won't be executed. And we will straight away jump to line number 9, where we are just going to say end while, and this will be the end of the dry run. So this is one sample dry run of this particular example. Okay. So let's consider that, we want to do another dry run. Okay. So this is one dry run. So we can have another dry run where, what we can say is that, let's say we need to draw that table again. So I'm quickly going to do that. So we have one column for instruction numbers, then we add a column for this variable gross sales. Then we add another column for this expression, which is gross sales is greater than 0. And we try to do another dry run. So remember the same rules that, we execute serial number 1. And where we are declaring this variable gross underscore sales. So we have declared, but we don't know what's in it. So it's a question mark and a hyphen. We go to statement number 2. It's a display statement. So nothing is going to change. So it is going to stay exactly the same. And in statement number 3, so let's try this number. Okay. So now we say that the gross sales that the user has entered is 50,000. And still we don't know about this expression. So leave line number 4, because remember, this is just white spaces. So move to statement number 5. So in statement number 5, we're going to evaluate this expression. So this expression now becomes true. So remember, this is a positive number greater than 0. So this expression is true. So the next statement that will be executed is number 6. So again, number 6 is going to display something to the users, but this is not important for dry run. Why it is not important for dry run? It could have been important if we were sort of storing this expression in a variable, but since we are not, so this is not really important. So we can just skip this. So again, it doesn't really matter, so just hyphen, because in line number 5, it was important that how this expression actually evaluates. So we move to line number 7, or you can say that this is true. So this is going to stay true here, okay? So we move to line number 7, and we are again asking the user to enter the gross sales value. So again, still when this statement number 7 is executed, this is going to be 50,000, and the value of this expression is going to be true, because and then we come to line number 8, and here the user is going to enter another value for gross sales. So let's say the user enters another value, and that is 20,000. So when the user enters 20,000, so what is going to happen now is that we are going to jump back to the start of the while loop again. So from statement number 5, we'll again go to number 5 now. So remember, now the value of the gross sales is 20,000, and we will evaluate this expression again. So again, the value of this expression is going to say true. So we will go and do these expressions, all of them again. So we'll do after 5, we'll do 6, we'll do 7, and we will do 8. So again, so we will repeat all these, and these values are going to stay the same. And let's say now when the user is at statement number 8, so again, we are expecting the input from the user. Says, let's say the user enters a negative number. So let the user enters minus 1,000. So as soon as the user enters a negative value, we are going to go back and evaluate. Again, because we need to go back. So we'll go at number 5 and evaluate this expression. So now, because this is a negative number, so this expression is evaluated as false. And then we jump to statement number 9, which is essentially saying that our repetition structure has ended. So, so here is, so this dry run ends here. So, this was a slightly extended dry run. So this can happen with repetition structures, because you can actually see that there is repetition. So there is repetition here, 5, 6, 7, 8, again 5, 6, 7, 8, and again 5 and 9. So there is repetition here, right? So apparently our logic is fine, and the solution that we have designed, or the algorithm that we have written, it looks that it is working absolutely fine. So I hope this gives you an idea that how to do dry runs, with the decision structures and with repetition structures. What should we consider when we are doing a dry run, and what is the purpose of doing multiple dry runs? So I hope this was helpful. I'm going to post this on the Google Classroom. So if you have any questions, you can leave your comments, and I will try to respond to your comments. Thank you very much.